We are going to look at the counting principle. On the counting principle, you must be careful when they say letters are repeated, or when they say letters are not repeated. I'm just going to illustrate that. All right, we're looking at the counting principle. All right, and then on the counting principle, I'm going to maybe give you an example whereby they say, consider the word hippopotamus. Then they're going to ask you a question that in how many ways can the letters be arranged to form different words? Let's say A, if letters can be repeated. But the other thing is, if letters is part 2, if letters cannot be repeated. Okay. All right, let's start with the whereby they say letters can be repeated. In how many ways? In how many ways can the word be arranged? Can the letters of the word be arranged to form different words? Okay, if letters can be repeated, I'm emphasizing on that. If letters can be repeated. If letters can be repeated, you just ask yourself, how many letters are there? We can find out it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are 12 letters. These are the 12 letters. And if we can repeat letters, you know that this H, the first position of any word which is going to be made by this word hippopotamus, it can take how many letters? It can take 12 letters. So you're going to say 12 times 12. The second one can take 12 letters again. The third one, those letters can be repeated. So even O can go there how many times? 1, 2, 2 times then. So that's why there are 12 of them. 12 times, I'm just going to say times 12. But how many are they? How many letters do we have there? And how many positions do you have there? There are 12 positions. So it's 12 times. So in other words, it is 12 to the power of 12. That would be the answer for question A, for question 1. Question 2, if letters cannot be repeated. If letters cannot be repeated. All right, you're going to ask yourself, hippopotamus, how many H do you have there? We only got one H. How many eyes? Only one eyes. How many P's? You know that you got 2 P, 1, 2, 3. 3 P's. And then how many O's there? We've got 2 O's. Alright, and then how many T's? Only one. How many A's? One. How many M's? One. How many U's? One. How many S? It's only one. But if letters cannot be repeated, what are they saying? All right, the first position, it can take all these letters. It's how many are they? We can just from the previous example, we can say that it can take 12 of them. But as for letters P, it's only one P that we are going to consider. So in other words, 1, 2, 3. We're only going to consider 1. So whenever they say cannot be repeated, you are going to say this. You're going to use what is called factorial. You're just going to say equals 12 factorial, because there are 12 of them, over, we are going to repeat p's. P's are going to be repeated 3 times, so we don't need to repeat. So it's over 3 factorial, because there are 3 p's, and then 2 factorial, because there are 2 o's. So let me just say this one, it represents the 3 p's, and this one represents the 2 o's. Okay, and then this one, because there is no repetition, no repeating of letters, no repeating of letters, and we only got 12 of them. Okay, then you use a calculator. You're going to say 12, there's 12 factorial, you can get 12 factorial. On your calculators, there's a sign which is like this. There's a sign which is like this. This is the factorial, so you're going to say 12 factorial. Factorial over 3 factorial multiplied by 2 factorial. Alright, you must be careful here. It is 3 factorial multiplied, because actually if you punch into your calculator like 2 factorial over 3 factorial, then 2 factorial, is going to give you error, because you must put multiplication sign there. So your answer should be 39916,800. That's it. That's the answer. Alright, let me just give another letter quickly, then I'll come back to hippopotamus. Let me just, because I feel like I must give you another example. Okay. Maybe they might say, consider the word, consider the word, maybe let's say the word football. Then the first question is that in how many ways can the letters of the word be arranged to form different words, because we're going to have different words then. Alright, let's say the first one, this is the first condition. If letters can be arranged, okay. But let us just deal with if letters can be repeated. Let us deal with if letters can be repeated. Alright, if letters, you just ask yourself, how many letters are there in this word football? 1, 2, 3, 4, 5, 6, 7, 8. There are 8 of them, isn't it? So in other words, you're just going to say 8 to the power of 8. 8 to the power of 8, it gives you 8 to the power of 8. It gives you 1677 7216. If letters can be arranged, if letters can be repeated. The second part, if letters cannot be repeated. Alright, if letters cannot be repeated, you're just gonna say, how many letters do you have there? We've got 8 of them. So you're gonna say 8 factorial over those letters that are repeated. You can see that O is repeated twice. So in other words, it's O, which is 2, it is repeated twice, so it's 2 factorial. Then you can see that L is repeated twice, so it's 2 factorial. So whereby you're going to get 8 factorial over 2 factorial times 2 factorial, which gives us 10,080. So if letters can be repeated, you see this 2, it represents O. We can see that letter O is repeated twice, so you write it 2. If it is repeated maybe thrice, you are going to say 3 factorial. If it is repeated 4 times, you're going to say 4 factorial. And then L, you can see we got 2 L's here, so it's 2 factorial. Then 8 over 2 factorial multiplied by 2 factorial. Maybe, for example, let's just consider this word whereby there is no repetition. Let's just consider the word not this word. Maybe let's consider the word let's consider the word game. I say game out. Okay. All right. Let's start by one way letters can be repeated. You can see that 1, 2, 3, 4, 5, 6, 7. 7 to the power of 7. If you say 7 to the power of 7, you're going to say 7 to the power of 7. Then you get 8, 2, 3, 5, 4, 3. Okay, that's 7 to the power of 7. If letters can be repeated. Then part 2, if letters cannot be repeated, you can see that A is not, G is not repeated, A is not, M is not repeated, E is not repeated, O is not repeated, U is not repeated, T is not repeated. You just want to say there are 7 letters, so it's 7 factorial. Only 7 factorial. Because there is no other letter which is repeated, so it becomes 7 factorial. 7 factorial. So it's 7 factorial, you get 5040. All right, in this next example, we're going to look at probabilities involved when we arrange letters. For example, you'll be given that, consider the word hippopotamus. I'm going to use the word hippopotamus because it is a little bit longer. Consider the word hippopotamus. And then the question is that what is the probability that the random arrangement, what is the probability that the random arrangement of letters of the words starts and ends with O. All right. That the word starts with O, it starts and ends with O. So in other words, this word hippopotamus is going to start with O and it is going to end with O. So how many letters are there here in between? We know that there are 12 letters. There are 12 letters, and the 2 letters now, we've got 2 letters at the ends. The one it starts with O and the end it ends with O. So we are supposed to have 10 letters. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 letters in between. So that's how we are going to work it out. But before, you know that for us to calculate probability, we know that probability that its word starts and ends with O is given by the number of arrangements number of arrangements. Or let me just write it down. Let me just come down here. It is given by number of arrangements where it starts and ends with O. Okay. Over total possible number of total possible arrangements. Okay, total number of possible total arrangements. Okay, let's start with the numerator. Number of arrangements whereby it starts and it ends with O. Starts and ends with O. Alright, we know that there are 12 letters, and in between there are 10 letters. So we are going to arrange 10 letters. So in other words, for the number, let me just say number, number of words, where it starts and ends with O. It's going to be given by, we know that there are 10, in between there are 10 of them, so it's 10 of them, over, so it's 10 factorial, over, these two O's, they're out, isn't it? So you're left with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then from those 10 letters, we are going to repeat P. So it's 10 factorial and 2 factorial, because P is repeated twice. So it's 2 factorial. Then total possible arrangements is just going to be given by, total possible arrangements is just going to be given by how many letters of the word hippopotamus have? It has got 12, so it's 12 factorial. And how many repetitions? We've got 2 P's, which is 2. We've got, we've got 3 P's. Yeah, so it's supposed to be 3. I just noticed 3. It's 1, 2, 3. 1, 2, 3. So it's 3 factorial. So we've got 3 factorial for 3 P's. And then we've got O factorial, which is 2 of them, which is 2. The number of O's, there are 2, so it's 2 factorial. So which means, therefore, the probability of what we want, word starts with O, starts and ends, word starts and ends with O, is given by total number of arrangements, which is 10 factorial over 3 factorial divided by 12 factorial over 3 factorial, 2 factorial. I'm just going to use my calculator quickly. So it's going to be 10 factorial over 3 factorial divided by 12 factorial over 3 factorial times 2 factorial. So the probability is going to be 1 over 66. 1 over 66. That's the probability. Okay? I'm going to give you another example. A computer program comes on a CD. A computer program comes on a CD with a pin code of 5 characters. To unlock the program on installation, to unlock the program on installation the pin code on the letters of the alphabet. All right, the pin code is made up of letters of the alphabet and or digits. All right, then the question is, how many possible pin codes can be generated? How many possible pin codes can be generated for the program if they how many possible pin codes can be generated if letters or digits should not be repeated. Okay, let me just read this. A computer program comes on a CD with a pin code of 5 characters to unlock the program on installation. The pin code is made up of letters and of the alphabet, letters of the alphabet, and or digits. How many possible pin codes can be generated if letters or digits should not be repeated? So first of all, you know that it is a 5 pin code. So 5 pin code, in other words, we are going to have 5 spaces where we are supposed to punch in these codes. So for the first, and letters and digits cannot be repeated. So first of all, you must ask yourself, how many characters must be on the first block? You can see that how many letters are there of the alphabet? There are 26 letters. And how many digits do we have? We have digits from 0 to 9. So from 0 to 9, we have 10 digits. We have 10 digits. Okay, so in other words, it's 10 letters, it's 10 digits plus 26 digits, which makes how many characters? 36 characters. So the total number of characters is 36. So how many of them must be on the first block? So we are choosing from a pool of 36 characters. So you write 36. So the first letters can be taken by 36 of these characters. But they say it must not be repeated. So in other words, it is 36 multiplied by, let's say if you choose one of the characters, it means now for the second block, you are going to choose from 35 characters. So 35, now there are 2 of them, you choose from 34. Now there are 3 of them already, choose from 33, then 32 multiplied by. So in other words, just going to say 36 multiplied by 35 multiplied by 34 multiplied by 33 multiplied by 32. Let me just multiply that using calculator. 36 multiplied by 35 multiplied by 34 multiplied by 33 multiplied by 32. Whereby I'm going to get 4523940 codes. So these are the codes that can be generated.